What is the difference between transform and fit_transform in sklearn? In the sklearn Python toolbox, there are two functions transform and fit_transform about sklearn.decomposition.randomizedpa. The description of two functions are as follows. But what is the difference between them?
The .transform method is meant for when you have already computed PCA, i.e. if you have already called its .fit method. So you want to fit randomizedpa and then transform as. In particular, PCA.transform applies the change of basis obtained through the PCA decomposition of the matrix X to the matrix Z. In scikitlearn Estimator API. Fit, used for generating learning model parameters from training data. Transform, parameters generated from fit method, applied upon model to generate transformed dataset. Fit_transform, combination of fit and transform API on same dataset. Check out Chapter 4 from this book and answer from Stack Exchange for more clarity.
These methods are used to center/feature scale of a given data. It basically helps to normalize the data within a particular range. For this, we use z-score method. We do this on the training set of data. 1.fit method calculates the parameters mu and sigma and saves them as internal objects. 2.transform method using these calculated parameters apply the transformation to a particular dataset. 3.fit_transform joins the fit and transform method for transformation of dataset. Code snippet for feature scaling/standardization after train_test_split. We apply the same training set same two parameters mu and sigma values, parameter transformation on our testing set.
Why and when use each one of fit, transform, fit_transform. Usually we have a supervised learning problem with X, Y as our dataset, and we split it into training data and test data. Imagine we are fitting a tokenizer. If we fit X, we are including testing data into the tokenizer, but I have seen this error many times. The correct is to fit only with X_train, because you don't know your future data, so you cannot use X_test data for fitting anything. Then you can transform your test data, but separately. That's why there are different methods. Final tip: X_train_transformed equals model.fit_transform X_train is equivalent to X_train_transformed equals model.fit X_train.transform X_train, but the first one is faster. Note that what I call model usually will be a scalar, a fit transformer, other kind of vectorizer, a tokenizer. Remember, X represents the features and Y represents the label of each sample. X is a data frame and Y is a pandas series object, usually.
Do you also want to search on